Hello guys, so today we are going to see what is a telescopic series. So you are saying, wait a minute, what is telescopic series? Telescope is in physics, not in maths. So what the telescope is doing in maths? So let me give you an sequence. Like this is a function of f of x, and the sequence is it like f of 1, f of 2, f of 3, f of 4 till infinity. Okay. So we are going to derive a sequence from this f of x. Like we are going to derive a sequence whose first term is this f of 2 minus f of 1. Second term is f of 3 minus f of 2. And third term is f of 4 minus f of 3. Okay. This is also a sequence. Okay. So this sequence is called a telescopic series. Or in the other words, we can say that if a series consists of the difference of two consecutive terms in that series, so this series is called a telescopic series. So where we are going to use this telescopic series? If we find a sum, if we are going to find the sum of all of these elements, then the sum is really easy. Okay, like if you need to find the sum of this sequence. Okay, so what is it going to be? F of 2 minus f of 1 plus f of 3 minus f of 2 plus f of 4 minus f of 3. And we are going to compute the sum till n terms, so we can say f of n plus 1 minus f of 1. Okay, this is what sum of n terms. So here we can see that this f of 2 cancel out with this f of 2, this f of 3 cancel out with this f of 3, this f of 4 will cancel out here something, and till this f of n will also get cancelled out. So what is the remaining sum? This is f of n plus 1 minus of f of 1. Okay. So if we find a telescopic series in the sequence, then their sum will be very easy task for us to do. Okay. So here I am going to take an MIT integration B finals problem. So let us see how we apply this telescopic series in that question. Okay. This is our question. And what is this? This is greatest integer function. Okay. Like if we put 2.2 in this, then the value is 2. And if we put minus 2.2, then the value is minus 3. Greatest integer function means the lowest integer from this number, or we can say the lowest integer from this one, that is the greatest. Like we have a number line here 0, 1, 2 and minus 1, minus 2. Okay, so 2.2 is somewhere like this. So smallest from this, the smallest greatest integer is 2, and this 2. Minus 2.2 is like where here. So from this, the greatest smallest integer is minus 3. Okay. Now what we are going to do, we are going to write the equation first. Like 2 to infinity greatest integer of x multiplied by x squared divided by x raised to power 6 minus 1 dx. If we don't have this greatest integer, suppose if we don't have this greatest integer, then what we are going to do? So we are seeing in the upper part that this is x square dx. So we need to substitute something that's differentiation comes out to be x square dx. Oh, we can substitute x cube equals to some u or t. Then this is substituted. But the reason is that we have also here this greatest integer function. So what we are going to do? We are going to do this question from like if x is between 2 or 3. So this greatest integer of x is a constant and its value is 2. And if x is between 3 to 4, so this greatest integer function comes out to be 3. Okay. So can I write this equation as like from 2 to 3, this is 2 multiplied by x squared divided by x raised to power 6 minus 1 dx. Okay. Plus 3 to 4. From 3 to 4 it is 3. 3 x squared divided by x raised to power 6 minus 1 dx. Okay. And we can write this till infinity. Okay. So if we are going to solve one by one, then this is going to take a lot of time. Okay. What we are going to do here, we can say that this is something, the lower limit is 2, this greatest integer part is 2, lower limit is 3, greatest part is 3. So can we say that integration from a to a plus 1, okay, and here we have a, x square divided by x to the power 6 minus 1 dx. So here I have written a term of this sequence. What is a? A going to vary. A going to vary from 2 to infinity. So we can use the summation sign of here. A from 2 to infinity. So this is a simplified version. Okay. Now we can calculate first this integration. Okay. So first we are going to substitute x cube equals to t. So we can say 3x square dx equals to dt. Then x square dx. This is going to be dt divided by 3. Simple. Okay. Now what we have, like summation a equals to 2 to infinity. And here what we have, like from a to a plus 1. Okay. So we have to substitute this for t. When x is a, then t is a cube. And when x is a plus 1, t is a plus 1 cube. And this is, here is a. This is a constant for a particular term. And now we can integrate this one. Like x square dx is dt divided by 3. 3 is come out to be here. And this is x raised to power 6. We have x cube equals to t, then can we say that x raised to power 6 is nothing but it is t square minus 1. Okay, simple. So this is an easy integral. You can calculate this one. Let us see. We are going a is equals to 2 to infinity, and a by 3 is outside the integration, a cube a plus 1 cube, and we can write this as 1 minus t minus 1 multiplied by t plus 1. यहाँ पर dt है. Now what we are going to do, can we write this t minus 1 multiplied by t plus 1 as 1 over t minus 1 minus 1 over t plus 1. Can we write this? No, we cannot write this, because this is what going to be t minus 1 t plus 1, and here comes t plus 1 minus of t minus 1. So t cancel out, minus 1 plus, so this is going to be 2 divided by t minus 1 and t plus 1. And what we have, 1 divided by t minus 1 t plus 1. So we have to divide this whole thing by 1 by 2. And can we draw this 1 by 2 outside this integral for the simplicity? Yes, we can. Okay. Now what we have? We have a simple integration here. A divided by 6 and 1 over t dt integration is ln t. I have explained these in my previous videos on this channel, so you can watch after this video. Okay. So this is ln t minus 1 minus of ln t plus 1. From where? A cube to a plus 1 cube. Okay. Can we write this as a equals to 2 to infinity a divided by 6 ln a plus 1 cube minus 1 divided by a plus 1 cube plus 1. Okay. Minus, we can write this as ln a cube minus 1 divided by a cube plus 1. So this is a weird, as you can say, this is a weird expression. So let us simplify this one. We multiply this a inside, okay, and this 1 by 6 comes out because this is a constant. A equals to 2 to infinity. A multiplied by ln a plus 1 cube minus 1 minus of a ln a plus 1 cube plus 1. Yeah, this is correct. Minus of a ln a cube minus 1, and this minus plus, then this is a ln a cube plus 1. Okay, what we are going to see here, this is a plus 1 minus a plus 1 cube minus 1. This is also a plus 1 cube plus 1. Can write this as like minus, we can take common out minus 1, and this is a simple expression. This is a plus 1 cube minus 1, this is also a plus 1 cube minus 1, this is a cube minus 1, this is also a cube minus 1. So we are getting a sense that it can be modified into a telescopic series. Like this is an, so this has to be an plus 1. But right now what we have, that this is a, this has to be a plus 1, this also has to be a plus 1. What we can do, we can add add ln a plus 1 cube minus 1 and also subtract this one. Let me do. Okay. So what we have here up to 1 over 6 a raised to 2 infinity. If we have here a plus 1 ln a plus 1 cube minus 1, okay, minus of a plus 1 ln a plus 1 cube minus 1, and in minus what we have, minus of a ln a cube minus 1 minus of a ln a cube plus 1, okay. But we have added these terms, so we also have to subtract these terms, okay. So what we can say, minus of ln a plus 1 cube minus 1, okay, and we have subtracted this minus of ln a plus 1 cube minus 1, so we have to add this. So plus ln a plus 1 cube minus 1, sorry, this is plus 1, yes, yeah, this is plus 1, so here what we have, this is plus 1, okay. So can you see this is a telescopic series? And what we have to do, we have to sum up all of these, and the sum of telescopic series is quite easy, as we know this. So we have to simplify this one, like how we are going to solve this one, okay. So first step aside this one and work on only this one. So I am going to write this in a next page so we can simplify this easily, okay. Yeah, sure. Okay, so we have this series. So this is, we can say, this is a plus 1 या फिर a या फिर this is n of a plus 1 minus n of a, okay. Then this is going to be n of a plus 2 minus n of a plus 1. So we can start this like this, a of 3 minus a of 2, okay. Like we are going to say that a is equal to 3 in this expression, and the function is same. Then the next one is a of 4 minus a of 3, then a of 5 minus a of 4. So this is going to be cancelled out. What we have left, minus of a2, and we are going to further. So if in n term, what we have, a of n plus 1 minus a of n, a of n gonna cancel out, but this a of n plus 1 not gonna cancel out. So we will write this just these two terms, okay. So first we write minus of a of 2 minus of a ln a cube minus 1 minus of a ln a cube plus 1 at a equals to 2 प्लस लिमिट लगानी पड़ेगी यहाँ पर अपने को अभी, क्योंकि जो n है वो तो इन्फिनिटी की ओर जा रहा है. So this is a equals to n plus 1, and we can common out this n plus 1, and then this is going to be ln n plus 1 cube minus 1 divided by n plus 1 cube plus 1. Okay. So we have these two expressions. First one we can calculate. First one is, what is this? Minus of 2 ln 8 minus 1. Okay, minus of 2 ln 8 plus 1. Okay, this is going to be minus 2, we can common out ln 7 by 9, and this minus also comes in. So this is 2 ln 9 by 7. So we calculated this part, and for this part n is going to be infinity, and we can say that this number at the infinity, this number is going to be 1 at least. Okay, if this number is 1 and ln of 1 is 0, and this n plus 1 is infinity multiplied by 0. So what we can do in this relation? Okay, so we can use L'Hospital in these kind of expression, but we have to modify some of the things. Like first we take this one apart. Okay, so this is our expression. Can we write this is as limit n tending to infinity, and this ln part is in numerator, and this n plus 1 part we can take this in denominator. So when n tending to infinity, this number is 0, and when n tending to infinity, this number is 0. So we can apply here the L'Hospital rule. Okay, so in this rule, what we are going to do, that something like that, limit x tending to 0 1 over x and sin x. Okay, this is the form of upper part is 0, lower part is 0. So we can differentiate both upper and lower part in terms of the limiting quantity. So limiting quantity here is x. So we can differentiate sin x, then upper part is cos x and the lower part is 1, and limit x tending to 0. And when we put 0, cos 0 is 1, so this limit comes out to be 1. And the same thing we are going to do here. Okay, so differentiating the log part, so first we get 1 over the part. So the numerator and denominator just change out, as you can see. Now we apply the integration by differentiation by parts, or differentiation of a fractional expression. So differentiation of a fractional expression is look like this, like this is f of x divided by g of x d by dx. So this is going to be gx square, then gx f dash x minus g dash x fx. Okay, so differentiation is that if we have ln, so we have differentiated first the ln only. So ln differentiation is 1 over x. X is this quantity, this full quantity is x, and now we are going to differentiate this quantity in terms of n. So this is going to be n plus 1 cube plus 1 square, then this is n plus 1 cube plus 1 multiplied by 3n plus 1 square. We just differentiated fx, or you can say the numerator, and then we have also come across 3n plus 1 square multiplied by this n plus 1 cube minus 1 part. Okay, And in the denominator what we have? I just write it down. In the denominator what we have just 1 over n plus 1, and its differentiation is comes out to be minus 1 over n plus 1 square. Simple. Okay. So now we can see that this cancel out one time, and in the numerator this 3 multiplied by n plus 1 square, this comes out to be fine. And this n plus 1 cube plus 1 minus n plus 1 cube minus 1, okay, divided by n plus 1. This is like a cube minus b cube. This is a cube plus b cube, okay, minus 1, and this is n plus 1 cube plus 1. Then in the denominator minus 1 over n plus 1 square, okay. So we can say that this is 3 times n plus 1 raised to power 4, and in multiplication this n plus 1 cube cancel out and just 2 remains, okay. And in the denominator what we have, n plus 1 raised to power 6 plus n plus 1 cube minus n plus 1 cube minus 1. This also cancel out. So what we have, 6 n plus 1 raised to power 4 divided by n plus 1 raised to power 6 minus 1. So n is tending to infinity, limit n tending to infinity. So we can say that this is almost n plus 1 raised to power 6. Okay, so limit n tending to infinity 6 divided by n plus 1 square. So this is going to be 0. Sorry, n tending to infinity. So this number is 0. So we have got to know that this multiplication is 0 and this is 2 ln 9 by 7. Now come at the starting part. So this expression is comes out to be what, 2 ln 9 by 7. And here we can also add the limit sign. Limit a equals to infinity. Now what we have, 2 ln 9 by 7 minus of this part. This minus is for whole. So this is also minus. Okay. Minus 1 minus of ln a plus 1 cube plus 1. Or we can write this as 1 over 6 2 ln 9 by 7 plus limit a equals to 2 to infinity ln a plus 1 cube plus 1 minus ln a plus 1 cube minus 1. Okay. So how to solve this part? Like this is not like a telescopic series or something else. Can we make this a telescopic series? So for that we know that this a a plus b cube is like this. A cube plus 3ab multiplied by a plus b cube. You know this? And can we write a plus b cube minus of 3ab plus b is equals to a cube plus b cube. So we can common out a plus b. This is a square plus b square plus 2ab minus 3ab equals to a cube plus b cube. So this is comes out to be a plus b multiplied by a square plus b square minus 2ab is equals to a cube plus b cube. Now we replace b as to minus b. So this is a cube minus b cube. This is a minus b. This is a square plus minus b square is comes out to be b square. And this is plus 2ab or ab, sorry, minus ab plus ab. Okay. So we are going to use these two formulas to break apart these two equations. Okay. So can we write this as ln of, what is the formula? A plus 1 plus 1. So it is a plus 2. And this is comes out to be a plus 1 plus square. So a square plus 2a plus 1. We can write this as plus b square. B square is 1 minus of a multiplied by b. It is this minus ln a plus 1 cube minus. So it is a plus 1 minus 1. It is comes out to be a. And this is a square plus 2a plus 1 plus b square is 1 minus of a plus 1. Is it correct? Like this is a plus 1 square plus b square, so plus a plus 1. Okay, is it correct? Yeah, sure, it is correct. So can we write this is a equals to 2 to infinity ln a plus 2, and this is a square plus a, this is minus a plus 2a plus 1. Okay, minus of ln a multiplied by, can you write this is a plus 1 square? Yeah, sure, a plus 1 square plus a plus 1 plus 1. Okay, so here we can see this is a square plus a plus 1. This is just next term of it. Okay, so we are getting somewhere. We just going to separate out these things. A equals to 2 to infinity ln of a plus 2 minus plus ln of a square plus a plus 1 minus of ln a minus of ln a plus 1 square plus a plus 1 plus 1. Okay, so we separate out these two things. Okay, a equals to 2 to infinity ln a plus 2 minus ln of a. Okay, then after what we have, a equals to 2 to infinity ln a square plus a minus a plus 1 minus of ln a plus 1 square plus a plus 1 plus 1. Okay, plus 1 is here. We can just plus 1 is here. Okay, so this is sort of a telescopic series. Like this, it is not a consecutive term, but the terms are repeating itself. Okay. Our first expression is a equals to 2 to infinity ln of a plus 2 minus ln of a. Okay, so we can write this as a function, like this is something a of 4, like a of 2 or 2 plus 2 is 4, so the function is ln of x. You can say a of 4 means ln of 4, a of 4 minus a of 2. Okay, we are starting from 2. This is a of 5 minus a of 3 minus a of 4, so this is minus a of 6. Okay, till now we are going to give the n as a final. Okay, n. Okay, and this n tending to infinity. Okay, so this is a n, and what this comes out to be a of n plus 2. This is a n minus 1. This is comes out to be a n plus 1. Okay, and this is a n minus 2, and this is comes out to be a n. So this 4 is cancelled out by this 4. 5 is also get cancelled out. 6 is also get cancelled out. This a n is also get cancelled out, but this a n plus 1 and a n plus 2 is not going to cancel out, and this a2 or a3 is also the same, and the function is ln x. So we can write this is minus of ln 2 and minus of ln 3. This is comes out to be constant, or we can say these two terms are not cancelled out. Plus we can say that limit n tending to infinity, and what we have ln of n plus 1 plus ln of n plus 2. Okay, so this is what minus of ln 6 we can say, or not? Yes, can we say this? Yes, sure, we can say. Plus limit n tending to infinity ln of n square plus 3n plus 2. Okay, so this is the expression we are going to get. Simple. So can we write here as like minus of ln 6. Okay, minus of ln 6 plus limit a equals to 2 to infinity, sorry, minus of ln 6 plus limit capital N tending to infinity ln n square plus 3n plus 2. Okay, this is the simple expression, and by the same logic we are going to solve this one. Okay, so let me write this one. This is what limit a equals to 2 to infinity, and this is ln of a square plus a plus 1 minus of ln of a plus 1 square plus a plus 1 plus 1. So this function is like ln of x square plus x plus 1. Function is like ln of x square plus x plus 1. So this is a2 we can say, this is a3, then a3 minus a4, then a4 minus a5, then we can say an minus of an plus 1. Okay, so these terms are going to be cancelled out. Sure. 4, 3, 3, 4, 4, 5, 5 as far as this an. So a2 minus, so what we have here, a2 minus a of n plus 1. So we can write this as ln of 2 square plus 2 plus 1. Okay, minus of limit n tending to infinity, and this is comes out to be n plus 1 square plus n plus 1 plus 1. Okay, so this is what 2 square 4 6 and 7. ln 7 minus limit n tending to infinity, and this is like n square plus this is 3n plus 3. This is also capital N. Okay, so we will write this expression above. What is this? Plus ln 7 minus limit n tending to infinity ln n square plus 3n plus 3. Okay, so this is ln 7 by 6. Can we say? Yes, we can. Plus limit n tending to infinity ln of n square plus 3n plus 2 divided by n square plus 3n plus 3. So this expression when n tending to infinity comes out to be nearly equals to 1. Okay, so ln 1 is 0. So we can say this expression is 0. So the whole part here comes out to be what? ln 7 by 6. Okay, this is our part, ln 7 by 6. 6. So now can we write that like 1 over 6 to ln 9 over 7 plus ln 7 by 6. No issue. 1 over 6, can we write this is ln 81 by 49 plus ln 7 over 6. Now can we write this is as 1 over 6 ln 81 multiplied by 7 by 49 multiplied by 6. Yes, sure, this is comes out to be 7, this is comes out to be 2, and this is 27. So what is our answer? Our answer is like 1 over 6 ln 27 by 14. Our answer is going to be 1 over 6 ln 27 by 14. Okay, so I hope you have learned something from this video. Keep watching, keep sharing the video. Thanks for watching. Keep learning, keep growing. Jai Hind.